All right, welcome. In this video I want to start pathing my archer and my footman towards my tower so they can attack it and be attacked by it. And I want them to walk along a preset path. For now I'm going to limit it to straight lines, but I want it to have different line segments so that it can path around other objects, and that way I could perhaps use this as the output of some pathing algorithm that will give me these line segments, and then all I need to do is get my footman and my archer to follow the line segment. In order to get started, I have animated my archer and my footman and their attack animations as well, not currently shown. And then I've also put some debugging effort in, and I've also gone ahead and I've created a bounding circle and a visual radius around each of them, both being a circle. And I've decided in this type of game that I want to use bounding circles to do my collisions instead of rectangles. Now, why have I decided to do that? The number one reason why I've decided to do that is just because it's easier. It's 100% easier than using rectangles, and I have no need for rectangles, at least in my visualization of the tower defense game that I want to build. It's possible I would be using rectangles, or there would be rectangles in my game when I would be placing my towers down on a preset grid and so on. But when it comes to my agents moving around the grid and interacting with other entities in the grid, I'm mostly going to be relying on circles. What that also means is that I've moved the XY coordinate of my agents now. It always used to be, at least I usually default to being the top left corner of the frame that I'm drawing, or at least of a rectangle if I'm dealing with bounding rectangles. But I'm now going to change that to be the middle of my entity, as close as I can get it. As you can see with my footman and my archer and so on, I've tried to center the middle of the circle around that entity, and I've done that with the archer. You can see the green box is moving around the sort of red box. That's because I've drawn the offset. I've offset my archer where I draw it so that the archer looks like it will be in the center of its own hitbox. The red is its hitbox. As far as the game is concerned, the red circle is where the archer actually is, and so I wanted to make sure that the archer was drawn inside that red circle. So I went through some effort to make sure that I drew them in the right location. I didn't nitpick right down to the absolute pixel, but you can see here, depending on which archer, which way he is facing, I'm going to offset that where I draw that frame so that the archer appears to be in the middle of that archer's bounding circle. Now again, that means that the actual location for the archer that we're considering, where is the archer, will be the middle point of that circle. Same thing for the footman, same thing for my tower and my arrow. Now the reason why I chose to do that also is I'm about to start pathing my footman and my archer, and I want to path them towards the tower, or at least towards some fixed point. I want that to be where the middle of the footman is going to eventually arrive, and I also want to path them not towards the top corner of my tower. I want to path them maybe towards the actual middle of my tower. And so this is just going to make sense for pathing, firing, shooting, aiming, walking towards almost all of the important things that I'm going to want to do. And so I've decided again to use circles instead of rectangles here. All right, I'm going to start with my footman. So I've commented out my archer and my arrow for the moment. The arrow actually should only be created when my archer or my tower actually fires one, so I'll probably just leave this out completely. But for now I'm going to work on my footman. I'm going to start my footman off over on the right hand side of the canvas at 1500, and then I'm going to try and have my footman move to a couple of positions. I've just tried to make 4 different kind of arbitrary positions, not so arbitrary. I'm trying to get my footman to move towards the upper left of the map, and I've made the last point, well, 0, 0, which is the top left corner, so eventually should reach the top left. Maybe that would be where the base would be for the tower defense game. Now I need to set up the footman actually taking in this path and using that to move and do something. I'm going to actually set up something else here. I've now got a path set up, but I'm going to set something else. I'm going to call this dot target. And that's going to be the point that I'm going to be looking for. And I'm going to just set that to be this dot path 0, the first entry in my path. Here I'm going to assume that I actually have a path. So I might as well put a little bit of error checking there to make sure the path is defined and make sure that it actually has a first entry. Otherwise I'll get an error, of course, if I try and access it. The idea I have behind this is that I'm going to change this target when I reach this first point. After I move towards it, then I will change it to the next point, and so on. I will iterate through. And I'll probably going to need an ID that's going to keep track of that, so I am going to set something else as well. I'm going to call that this.target ID, which will just be the integer, and then let's just quickly refactor that. So I can use this.targetID property to keep track of which point in my path I'm currently moving towards. And also, thinking ahead, foreshadowing here, I'm going to, at some point, if I see that tower, I want to move towards it. I want to change it to be my target, and this target ID will allow me, say, after I destroy the target, my tower, to move back to my original path and restart where I left off. So the next thing we need to do is we need to do a little bit of physics. We need to decide what is the direction from us to the target, the point that we want to move to. What I've done here is I've calculated what we call the relative vector. The points that we usually use to keep track of where an object or an entity is in a Euclidean space, in a two-dimensional space, the xy coordinate, is what we usually call an absolute vector. And that's because it is relative to the origin, which is 0, 0. A relative vector is where we calculate a vector that is relative to some point other than the origin. In this case, we're going to calculate a relative vector relative to our current location. And this is like treating our current location as the origin. And of course, for most of us, as actual entities or beings, that's how we think about the world. Our current location is the origin. And so when we want to think, where should I go? What's the direction I should go? We think of the world relative to ourselves. So that's what we're doing here. We're calculating a relative vector relative to ourselves. What is the direction I would have to move to reach my target? And to do that, we're just going to do a little bit of geometry here, where we're going to take the target's coordinates and we're going to subtract off our coordinates. That's the math that we have to do to basically translate the origin to be our location. So we will do that. We'll subtract off our coordinates from the target coordinates, and that gives us our relative vector. Now we're going to work with this relative vector because the relative vector itself, if we use it, if we treat the relative vector itself as a velocity, depending on how we're going to handle our velocity here, this will maybe move us to the point, our target point, in one tick. That's almost too fast. We don't usually want to do that. Or if we set it up as a velocity in sort of a ticks per seconds, then we'll get there within 1 second. Now, that might be okay, that might be what you want to do, but I'm anticipating that the line segments that I'm going to be on are going to be of different lengths. And I don't want my footman to be able to traverse longer line segments faster than shorter line segments. I want the length of the line segment to determine how long it takes me to move. Or another way of saying that, I want my footman to walk at a fixed speed. So what I'm going to be using here is this max speed, which is measured in pixels per second, in anticipation of having to do a little bit of circle geometry and circle math. I've created a distance function as well as our collide functions, which I'll get to in a second. But the distance function is just going to take 2 points or any 2 objects that have x and y's, and it will give us the distance, the Euclidean distance between them. So I will calculate the distance, and then what I'm going to do with this relative vector is I'm going to do this all in one. So it's no longer going to be a relative vector, it's now going to be a unit vector. I'm going to take this direction that I've calculated here, and I'm going to divide it out by the distance, and now this will give me a vector, still a relative vector, but now a relative vector of length 1, pointing in the direction that I want to go. Now if I take this unit vector and I now multiply it by my maximum speed, it will give me the velocity that I want to move in the direction of that I've calculated here of this unit vector. Now again, I'm going to do this all at once. So I'm now going to do multiplied by this dot max speed here as well. And since I've declared my max speed down here, I should probably make sure I declare that before I use it. And then the last thing I'm going to notice here is that what I've now defined is exactly what I want my velocity to be. So I'm just going to cut that. And I think I've calculated what I want my initial velocity to be. Now, with my initial velocity, I need to add some logic here to my update to move my footman in the direction of his velocity. And that's actually a little bit easier than it maybe sounds. We're just going to update our x and our y coordinate. So I'm close to having it correct here because I'm just going to be adding my velocity onto my x. Now the problem is my x is in position. We're going to treat it as a position in pixels, but my velocity, remember, was in pixels per second. So I need to know how many seconds it is that I've traveled. And remember that we had this stored in our game engine in the clock tick. That's going to be how long it's been since our last update. So I'm just going to use that value to determine how far I should move in the x and the y coordinate. The velocity vector tells me how far I should move in that direction, maintaining my speed of 100 pixels per second. All right, let's test. And we can see here that my footman is indeed moving now. I'm going to assume at a velocity of 100 pixels per second. That was about 8 seconds or so to traverse this. I'm not sure. All right, let's just test this. And we can see that, well, it looks like our footman is indeed moving to the left. That was the first direction that I had intended him to move. And he is moving there at a speed of, I assume, 100 pixels per second. I'm not exactly sure how wide I made this particular canvas. It's probably about 1,800, something in that range, pixels. And it looks like it's been about that many seconds for my footman to move across. Now the problem is I've used the point, my target point, to calculate my velocity, but my footman doesn't know to stop when he gets to the target, and that's the part of the logic I haven't built in yet. So that's the part I want to build in now. One quick way for us to make our footman stop, kind of stop at least, is continually update his velocity towards that position. Now, as long as we haven't reached the position, we will just keep updating and having the same velocity. But if we ever move past the point, our target, we will now update our velocity to move backwards. So let's see if that works. So we've got him walking. Let's just see what happens. And well, it looks like he's arrived at his point and he's now sort of confused. I guess he just goes back and forth, back and forth, back and forth. So now what I think I want to do is I want to add a little test, which is if I've arrived at the point, I want to change to the next point. But it's usually not a good idea to wait until we arrive exactly at the point. So instead what I'm going to do is I'm going to decide if I've reached a certain range within a certain number of pixels of the point, then I will switch to the next point. So now I've added a little bit of logic to just check if I'm close enough to that point, and I've decided 5 pixels. That's pretty small, that's a small window. If I'm within 5 pixels, I'm going to do this next check. Now the next check is saying, as long as I have another target in my list of targets in my path, then that's my first check for whether I want to advance to the next one. If I don't have another target, I will just stay on the last target and do my little stutter step. And then my second test here is anticipating that I'm going to start making buildings as targets as well, where my footman's going to walk up and attack a building. And so what this is saying is if your target is not the last point in the path, meaning it was a building, then don't advance to the next point in the path. Go back to your last point in the path. Keep going to that last point in the path until you arrive there, at which point you might target a new building or go on to your next point in the path. Then, once I've decided if I'm going to advance my target ID or not, go to that next point in the path, assuming I did, then I want to update to that next point in the path. That's what I do here. And then I just re-up on my distance. I calculate my distance again so that my distance is calculated properly in this vector down below. Let's see how this works. All right, so we've got our footman moving here, and when he gets to his point, okay, he moves, and we do see that my animation is working right. He's facing in the right direction, or roughly in the right direction for the way that he moves. Now he didn't detect the tower, so now I do want to add that logic of If he detects the tower, I want him to move towards the tower instead. And then I also want to maybe attack the tower. All right, so we're going to have to use our first bit of our collision detection logic now. And in this case, I'm just using collision detection with my visual radius, not my actual radius. We'll have to use my actual radius here in a second. But what we're going to be doing here is I'm going to iterate through all of the entities. That's the same thing we've done in some of our other collision detection videos. And I'm going to grab the first entity, or entity I rather, and just give it the name ent. If it happens to be the tower that I'm looking for, and I can see it. So to do this, I'm calling a little helper collision function that I wrote called canSee, and it's identical to my collide function. The only difference is in my collide function, I'm using my normal circle collide. If the distance between them is less than the sum of their radiuses, then there's a collision. The only difference I've added to canSee is that I use the visual radius of A and the normal radius of B to see if A can see B. So I call that helper function canSee with this being A and entity, the tower that I'm trying to reach, being B. And I'm going to say if I can see that entity, then I will make that entity my target. Now notice here, this is something that's beautiful about JavaScript, is that polymorphism comes for free. All that is important to me in my logic and everything that I'm working on here is that my target have an X and a Y. It's got to be a point. My entity, the tower that I'm trying to reach, does have an X and a Y, and it is the middle of that tower, and so that's the perfect thing for me to move towards. That's my target, so I just set my target to be the tower itself, and now I will move towards the tower. Let's see if that works. All right, so our footman's moving out. The footman shouldn't walk towards the tower until it reaches inside his visual radius, which we can see is the larger circle. And so once it reached that larger circle, he moved towards the tower, and we can see indeed he's sort of stuck walking towards that tower, stuck in that middle point. So now I guess we just need that last little bit of logic, which is if he actually reaches the tower, he should attack it. Okay, so now I'm going to use my other collision detector, collide, which is the same as visual radius, just uses the normal radius if my footman actually encounters the tower. Then I'm just going to change my state to 1, my state here meaning now attacking. And then I just added a little bit of extra logic down below here that I'm only going to do the walking stuff, the moving logic here, if I'm not in state 1, if I'm in state 0, which is my walking state. So this just stops me from walking when I reach the tower. Okay, and so the footman is walking out, and again the goal here is hopefully the footman will stop when he reaches the tower and attack the tower. And sure enough, our footman is attacking the tower. Okay, I guess the only thing that remains now is for the tower, I guess, to take damage, and then the footman to continue on his way. Okay, now I've added just a slightly little bit more logic, which includes a cooldown for the attack. I don't want every time I get a chance to update the footman, he deals more damage to the tower. That would be really rapid and real fast. Instead, I want every time he sort of finishes his attack animation, I'll do some damage to the tower. So to enable that, what I've done here is I've started by just checking the first time I come in here that I will be in state 0, that means walking, and so I'll change my state to 1, and I'll start out by just setting my elapsed time to 0. Normally, I'm going to be updating my elapsed time here, and so this is going to, every clock tick, update my elapsed time. So if it ever gets over 0.8 seconds, now I chose 0.8 seconds because we have a 4-frame animation for my attack, and I chose to put it on about 0.2 seconds per frame. That's about the speed that I thought looked kind of natural to me, and so I'm going to use that timing for the animation as my timing here for my cooldown as well. When I reach that 0.8 seconds, meaning I've been attacking for that 0.8 seconds, then I will go to my entity, the tower, and minus equal its hit points. I've decided 8 points of damage to the tower. That's just something I'll have to decide in balancing. And then I reset my elapsed time back to 0, allowing me to attack again. Let's see what happens. So the only other logic that I added to the tower was I gave the tower 100 hit points and one little update to its update where if the tower, if the hit points of the tower is reduced to less than 0, then the tower will remove itself from the game and should disappear. And there we go, it disappeared. So the tower seems to be working. It's taking damage and it disappeared. Of course, it looks like we still have maybe one last problem. Our footman is stuck in the attacking state. Okay, so I've just added one extra little line here, and that is I'm going to check to see if my target, now remember my target is either going to be a point, that's just preset, or it's going to be a tower. And so I've decided here to just check if that tower has a remove from flag world, a remove from world flag, and it is set to true, then that means that tower is about to be destroyed and removed from the game. So I will just check, and if that flag is set to true, I will set myself back to walking. Let's see what happens. So it looks like I've got everything I needed for my footman to walk to the tower and attack it. And I guess the next thing I want to do is have the tower shoot back. So that's going to be for the next video. So thanks a lot for watching, and we'll see you in that next video.